Hello everyone, I wanted to do a bit of a news video about Chromium in Linux, because I've actually got something else on the go. Doing a bit of gaming with Streets of Rage 4, since it just came out for Linux. It seems to have been ages since I did some gaming in Linux, and Ms. Quids and I have absolutely loved playing the older versions of Streets of Rage, or Bare Knuckle if you're in Japan. I'm going to definitely do a video about this. It's an absolutely pretty game. Anyway, on with the news. So, Linux Mint have regularly liked doing things the opposite to Canonical with Ubuntu, but for some reason they still base their distribution on Ubuntu, and Debian as well, yes, but one of their decisions has been to remove the ability to install snaps. But that led to problems with installing Chromium, because Canonical only supply Chromium as a snap package, which helps reduce the amount of testing and compile times, because they're just building one snap, and that covers the versions of snaps across all their supported releases of Ubuntu. No deb package, so what do Linux Mint do? Well, I believe they've been using the release from Debian, but that can be a little bit behind. So what they're going to do now is actually build their own release, and they're saying to guarantee reactivity and timely updates, we had to automate the process of detecting packaging and compiling new versions of Chromium. This is an application which can require more than 6 hours per build on a fast computer. We allocated a new build server with a high specification, a Ryzen 9 3900, 128GB of RAM, NVMe, and reduced the time to build Chromium to little more than an hour. So that's interesting. Of course, better not mention the impact on the environment here by building another application, but no, that's just a wider issue entirely. But anyway, it's going to be better to build it at one point. Maybe I'm a bit cheeky there mentioning the environment, but packaging, I'm sure a lot of resources are wasted on it. Time, energy, yeah. But it's interesting to see Canonical continuing to try and improve the snaps, because one complaint has been the startup time. A lot of that issue was solved with a font config cache optimization, but now they're using a different algorithm for compression. So they're saying security and performance are often mutually exclusive concepts. A great user experience is one that manages to blend the two in a way that does not compromise the robust, solid foundations of security on one hand and a fast, responsive software interaction on the other. Because this is a key feature of snaps, they are aimed more at the security side, as well as in theory simplifying packaging, and you can get it across different builds of Linux. Let's say Fedora, Arch and Ubuntu, which all use different types of packaging formats, but with snaps you just got one packaging format. So snaps are self-contained applications, which does actually increase their size. As a result, sometimes they have reduced perceived performance compared to the same applications offered via traditional Linux packaging mechanisms. We are well aware of this phenomenon, and we have invested a significant effort of time in resolving any speed gaps. So now they're reporting a new major speed improvement. It's 2 to 3 times speed improvement. By default, snaps are packaged and compressed using the read-only SquashFS file system using the XZ compression algorithm. This results in a high level of compression, but consequently requires more processing power to uncompress and expand the file system for use. On desktops, users may perceive this as a slowness. The time it takes for the application to launch. This is also far more noticeable on the first launch only, because the application data is cached in memory. Subsequent launches are fast, and typically there is little to no difference compared to traditionally packaged applications. So to improve startup times, they decided to test out the LZO compression algorithm. And as a test case, they decided to use Chromium. So for example, the XZ compression snap weighs in at 150 meg, whereas the one using LZO compression is 250 meg in size. So that is going to increase the download size, but reduce the processing power for decompression. Now I have to say personally, I don't really see the snaps as much of a hardship. I don't see them as much of a slowdown on my system, but then again, it is rather much more of a powerful system, and I'm well aware that if you have a low-end system, there is quite a difference in the startup time of a snap versus a traditionally packaged application. But then you've still got the comparison of a cold start application, so the first time you're starting it, versus a hot start where the application is cached in memory. So Linux is very clever at caching, so the second time run of an application is generally quite quick. And it's something we did notice on the Raspberry Pi, for example, that actually has a much lighter CPU compared to my desktop, but then I've argued that it's got much lower power requirements than my desktop. But they still end up with a bit of a slowness with Chromium. So while running our test, we observed a rather interesting phenomenon, primarily on Fedora 32, a workstation running on a particular laptop. They noticed the initial snap took about 60 seconds, whereas cold launches would take about 10 seconds. They analysed it further and actually found it was an issue with the font config. The font caching configs that they thought had previously been resolved. So there's a whole write-up of how they got to this point, and yeah, if you do want to try this out in your system to see if you are getting any particular slowness because of snaps, yeah, worth trying. But yeah, in regards to this particular issue, snap caches. So it indicates a possible problem with the font cache creation, something that used to affect snaps in the past but has largely been resolved. However, it would seem a similar or perhaps new problem of this nature may be affecting Chromium. So private snap caches are stored in a hidden .cache directory inside a common subdirectory for each snap. So there can be multiple types of caches, including font config and many others. With their run of perf pointing to an issue with font caches, it was relatively easy to determine whether this is the main culprit. Indeed it was. Deleting all other caches and keeping the font config directory in place resulted in the first time launch being near identical to cold launch times. But why was it so bad? So I looked at exact timestamps of each cache and discovered it was just one font taking the bulk at a time. Out of 50 fonts in a particular system, the caches for 49 of them were generated within 500 milliseconds altogether, whereas just one cache took 45 seconds to complete. And they determined it was the Google Noto font family that was behind it. The irony that font is actually quite heavily installed these days on a lot of Linux distributions that I see. And why not? That is a very well built font that is compatible with many different languages. So temporarily moving the font out of the user share fonts directory resulted in first launch times becoming almost identical to cold launches. So they came up with a fix, not just called removing all the fonts, because that's not a fix at all. So they determined from the exercise that Chromium Browser Snap was not using any Snapcraft desktop extensions, which come with multiple useful features including various common aspects used for desktop applications. Snapcraft extensions also help reduce the application size, which can contribute to faster startup time, both as common libraries will most likely already be loaded into memory, and due to smaller size of the application. Furthermore, in the case of desktop-related extensions, they also encode the best practices for the desktop application snaps, all of which help developers achieve better consistency and performance with their snaps. And they give an example of the GNOME calculator here, and also discuss about the KDE calculator, which, yeah. So the KDE calculator weighs in about 1 megabyte for the use of the KDE Content Snap. The typical application size would be about 100 meg otherwise, without those particular extensions being included. So the good news is we have implemented these changes in the Chromium Snap. The latest Chromium Stable Update, 86 point all of that, has been rebuilt against the GNOME 3.28 extension and is now available for testing in the candidate GNOME 3.28 extension channel. And there's the command line to install it. So is it worth me trying that, though, bearing in mind I use the KDE desktop? Possibly not. So I might hold off on that and see what they do for the KDE desktop. But as I said, I don't really find a problem with the startup time of snaps, but that is more about my system. So that was a bit of news about Chromium in Linux Mint and Ubuntu. Thanks for watching. I'll see you all later.